This video is for lesson 17-3, properties of similar figures. Learning goals are to identify properties of similar figures and to apply properties of similar figures to solve problems. First, let's look at the symbol that's used for similarity in geometry class. It is this single squiggle line. So when you see this, it says that one figure is similar to another figure. For example, quadrilateral ABCD is similar to quadrilateral A prime, B prime, C prime, D prime. It's telling us that these two figures have the same shape, but that they're probably not the same size. Now in this drawing we have rectangle ABCD shown, and we have rectangle A prime, B prime, C prime, and D prime shown. Notice that the quadrilateral with the prime symbols in the corners is the larger figure. The original figure is the smaller one. Now question A, describe a sequence of transformations that would map the small triangle onto the large triangle. It looks like we need to rotate it 90 degrees counterclockwise to flip it up on end, and then if we multiply by an appropriate scale factor, we can get it to the correct size. And we could write that series of similarity transformations like this. First, rotate around the origin 90 degrees. Then dilate around the origin with a scale factor of 2.5. Now the tricky part is figuring out that scale factor. Here's how I did it. In the original shape, I chose one of the sides, for example, side CD, and observed it was 3 units. In the new figure, I chose the corresponding side, C prime, D prime, and figured out how long that was. It is 1, 2, 3, 4, 5, 6, 7.5 units wide. So then I asked myself, what value of K would I need to times by to get the result 7.5? So 3 times what makes 7.5? Divide both sides by 3 to get the K alone, and we get K equals 2.5. Now let's do number 2 and complete this theorem. Each similarity transformation preserves angle measures. Angle measures stay the same from the original shape to the new shape after similarity transformations. So corresponding angles are what? I'll pause the video for you to fill in a word there. Now let's work on number 3. Write the ratios of the corresponding side lengths of the pre-image and the image. What do you notice about the ratios? Well, we had done this once already when we created the value for the scale factor of K. The one side of the original figure was 3 units long. The corresponding side in the larger figure was 7.5 units. Now that was when we looked at side CD. If we scroll back to the original picture, let's choose one of the other sides. For example, side BC. How long is that? It's 1, 2, 3, 4, 5, 6 units. And then find side B prime, C prime in the large triangle, it's this one, and count how long that is. Then make a ratio of those two numbers. A ratio is a fraction. So find the two numbers and make a ratio. I'll pause the video for you. That ratio is 6 to 15. Now what do we notice about the ratios? If we reduce both of these fractions, we'll get the same result. 3 out of 7.5 and 6 out of 15 both reduce to the same thing. Number 4. Kate is about to meet with her final client during the day. Remember in our first lesson of this activity, Kate is a graphic artist. She needs to create a wall mural. She can measure the length of the wall, but not the height. She has a prototype picture and knows that the wall and picture are similar rectangles. Kate needs to find the area of the wall. Question A, which sides of the two rectangles are corresponding? That would be the 14 feet and the 31.5 inches. Now question B, write 2 different proportions that could be used to find the height of the wall. We don't know the height of the wall, so it's a good idea to write a variable there. For example, the letter x. Now before we write our proportions, I want you to notice a very important thing. The wall has a unit of feet, and the prototype mural has a unit of inches. That's going to be a problem. When you do math, you need to have things measured in the same kind of units. So if we take the measure 14 feet and multiply by the fact that there are 12 inches in 1 foot, we can convert the 14-foot measure into inches. This is 168 inches. Now we have the length of the wall measured in inches and the length of the prototype image measured in inches. Now the problem is actually doable. So back to question B. Write these two different proportions. One way to write this is to say the height of the wall. Notice that when I said height of the wall, what I wrote was x, corresponds to the height of the prototype. That's the 18. As the length of the wall, the 168, corresponds to the length of the prototype, the 31.5. When you have two ratios equal to each other, that is called a proportion. Now I'm going to pause the video for you to write one more proportion. It's going to involve the x, the 168, the 18, and the 31.5. And you have to match up corresponding things, but there's one other way you can do this. Here it is. We could take the height of the wall compared to the length of the wall. If we take the height of the prototype and compare to the length of the prototype. So height to length, height to length. That's another legitimate way to make the proportion. Question C. Can the proportion x is to 18 as 31.5 is to 168 be used to find the height of the wall? Explain why or why not. I'll pause the video for you to answer this. The answer is no. And the reason is that the corresponding parts weren't correctly paired together. X is the height of the wall. 18 is the height of the image. But then down here we took the length of the image and compared to the length of the wall. So this was having to do with the wall. The 18 had to do with the image. But over here the 31.5 was the image and the 168 was a measurement about the wall. Wall compared to image, image compared to wall. Things are not in the right order to be corresponding parts. Now question D, what is the height of the wall? Show the work. So we can take either one of our correct proportions and solve those proportions for x. One way to solve a proportion is with cross multiplication. So using that first proportion with cross multiplication, it would be the x times the 31.5. So 31.5 times by the x, and that is equal to the other diagonal of numbers, the 18 times the 168. Then, to get the letter x alone, we divide by its coefficient, 31.5, on both sides of the equation. That crosses away and the letter x is alone. You'd take a calculator and type in this math problem and you'd have the answer for x. Now I'm going to pause the video. Please use the second proportion that we created and solve it with cross multiplication. Here is the work and the answer is 96 inches. Now because 96 inches is the same thing as 8 feet and the original drawing up here of the wall had a measurement of 14 feet, it would probably be a good idea to give the answer in feet to match with the 14-foot length. Now question E, what is the area of the wall? Show the work. Area of a rectangle shape can be found by going length times width. So take the length of the wall and the width of the wall, multiply them together, and you'll have the area. The answer is 112 square feet. So in this lesson, we identified properties of similar figures. Properties that we looked at are that the angles are congruent to each other and that the sides are in proportion to each other. That is, that we can write ratios of corresponding sides. Then we applied those properties to solve problems about figures. The specific problem that we solved involved finding the area of a wall.